All right, here's your study guide for the next exam based on Unit 4, Integration. Let's do it together. Obviously, you need to do it first, right? And then when you watch, you can get support. Copying what I'm doing is not learning anything. So you're given a point, you're given the derivative. Find another point on that same function. So there's my goal. This is a starting value question. So the y coordinate that it starts with is 3. And then you integrate. You integrate from the x value we started with to what we're looking for, which is 4. And we're going to integrate the derivative. And now use your calculator. That's it. So let's type that in our calculator. So 3 plus, press menu, calculus, integrate. And we're integrating from, oh, there you see it better. From 1 to 4. And then type in cosine. So the trig button, cosine. And then type in x squared. And then dx. Control enter. And you have your answer, 2.689. You can truncate. All right, number 2. You feel like typing this in your calculator, but don't. This is the fundamental theorem of calculus, part 2. So derivative and integration undo each other. It's a substitution question. So we plug in the top here and then take the derivative, and the answer is 0. Subtract. Now you substitute in the bottom, use parentheses. So wherever there's a t, that's what you put in. Now the hook is the derivative of that limit or bound. So that's 3x squared. And that's done. All right, write down the integral representing the area here, but don't do anything else, right? So this is an integration question. So the first thing I integrate is from 0 to, and it says it's x equals 1 is that line. So it's a 0 to 1. And to find the area, I need to know the top, subtract the bottom. So which one is the top curve? So if I look, that's the cubic one, right? The top one. So that's negative x cubed. Use parentheses. Plus 2x. Subtract the bottom. The bottom is the parabola. Is the bottom part of that curve. So the bottom is x squared, take away x. dx. And that's it. Just set it up. Top, subtract, bottom. 4. Which of the following is the midpoint of preceding? Well, you need to find it. So it's not even which of the following. What is the midpoint Riemann sum of this between 1 and 5 using 2 rectangles of equal width? So to find the width, you're going to go the upper bound, take away the lower bound. So that's 5 take away 1 divided by 2. Now, we're integrating from 1 to 5. X over x minus 1 dx. That's what we're doing. And the width is 2. Now it says use 2 rectangles, width of 2. So between 5 and 1, if the width is 2, add 2 to 1, and now the first one goes 1 to 3. Sometimes it's nice to have a visual. So it goes 1 to 3 and then to 5. So 1 to 3 is the first rectangle. Now, if it says a midpoint, what number is obviously in the middle? That's the number you plug in. So it's 2 over 2 take away 1. That's 2. And then what's in the middle here to plug in for the second rectangle? It's 4 over 4 take away 1. So I'm just going to leave that as 4 over 3. And that's it. Don't simplify it. Number 5. The region in the first quadrant is bounded by this. Which integral represents the volume of the solid? So write the integral whose base is a semicircle with cross sections to the x-axis. So this is an integration question. We're going to integrate from 0 to 2. If these are semicircles, so if I did an example of a semicircle, there's a semicircle. So if these are semicircles, then top subtract bottom is actually the diameter. So if I want to know the area of that, we know it's pi r squared divided by 2. That's a semicircle. But this radius, I have to divide that by 2 to get the radius. So top subtract bottom is the diameter. So I go top subtract bottom divided by 2. Now that's the radius. So I'm going to write this, pi r squared. Pi r squared divided by 2. There it is, pi r squared divided by 2. And the radius is top subtract bottom and then divided by 2. So the top is 4x minus x cubed. And then you take that answer, and the bottom is 0. So it's that, take away 0. So it's just that. And then divide it by 2, that becomes the radius, and there's the setup. All right, the sketch at the right shows this graph when x is greater than 0 and equal to 0. Set up but don't integrate a volume for revolving the region between 0 and 1 around the x-axis. So we're taking this and we're revolving it around. So by revolving around the x-axis, this is a circle, a full circle when you revolve it. So it's pi r squared. And it goes from 0 to 1. And then what represents that radius is just top subtract bottom. Now, f at x is already defined, so we don't need to write this ugly thing in here. So we know the radius is top subtract bottom. In this case, it's the function subtract 0 or just the function. So that's all we plug in here. And then that is the setup for revolving it between 0 and 1. That's it. And you might want to put that in instead of f at x would be the same answer. All right, turn the page. Good question to take your time on, number 7. You will see it on the exam. Traffic flow is defined at this rate. And it's defined in cars per minute. So it's good to know the units. And it says to the nearest whole number, how many cars? So when you go how many, and what you're given is a rate, you're going to integrate to find out how many. So I already know I'm integrating. And I'm integrating over 20 minutes. So that means I'm integrating from 0 to 20. I'm going to integrate that function. And that will tell me how many cars. That's it. So we're going to use our calculator. So I'm going to integrate, menu, calculus, integrate. And we're going to go from 0 to 20. And then I'm going to type it in. Be careful. So 72 plus 5 sine. Now we'll go t, that's fine. So t over 3 dt. And then how many cars did that give us? So 1,441. To the nearest whole number. All right, is the traffic flow increasing or decreasing at 7? And give a reason for your answer. So is that rate increasing or decreasing at 7? I got to take the derivative at 7. And if the answer is positive, it's increasing. If the answer is negative, it's decreasing. All right, so how do I do that? So menu, calculus, derivative at a point. We can use t, and the value is at 7. And then I type it in, 72 plus 5 sine t over 3. And the rate is negative 1.151. So what's the reason for your answer? So at 7 minutes, the flow of traffic is decreasing because, and you can be this simple, the derivative at 7 is less than 0. So because that derivative is less than 0, that means the rate is decreasing at that moment. Number 7. what is the average value of the function? Now, average value is an integration question. So we're going to integrate from 10 to 15. And we integrate that function. And then we divide by the difference of the bounds. All right. So now we just have to type it in. Oops. All right. So we're going to go create a fraction. We're going to go menu, calculus, integrate. And we're going to integrate from 10 to 15. Again, I'm going to have to type in 72 plus 5 sine t over 3 dt. And then in the denominator is 15, take away 10. So the average value is 68.204 cars. So on average, what's the average flow? And it indicate units of measurement. So once we do average value, it's not a rate. So the average value is that many from 10 to 15 on average. That's how many cars there are. All right, number 8, different question. Show an integral setup for the volume of a solid whose base is bounded by 2 to the x and 3 root x plus 1. If the cross sections perpendicular to are squares, then find the volume. All right, this is a calculator question. So we're going to graph this. So I'm going to go and I'm going to graph. Now if I have something there, I'm going to press tab and I'm going to erase that. So first I'm going to type in 2 to the x. Now the good news is here is it's color coded. So when I go 2 to the x, that color is blue. Then when I press tab and I go 3 root x, that's 3 root x plus 1, that's going to be a different color. And then when it says so now it's bounded. Now I need to find the right bound, so I need to stretch this out a little bit. So I need to go menu, window, and window settings. I need to push it to the right more, like 10 or something. All right, so now I see it. So the first bound is 0. I know it's 0 because they share that. So if I plug in 0, both answers give me 1. So I'm integrating from 0 to, well, that's one I don't know. So I need to know that point of intersection up there. So I'm going to go menu, I'm going to go analyze graph, and then I'm going to go intersection, which is number 4. And then I'm going to go to the left, and then I'm going to move it to the right. And then what is that point? So it's 2.529. I don't need the y coordinate. And I need to go top, subtract bottom. So we know the square root is on top. That's the red one. So 3 root x plus 1, subtract 2 to the x dx. So there's the setup, top, subtract bottom. And then now I actually have to type it in. Now you could actually do it right off the graph. So if I go menu, I go analyze. If I go bounded area, I can go to the left. I can actually type it in. So I can type in 0, enter, and then the upper bound, I can type in 2.529. So just type it in, enter, and then it will give you that shaded area. So the answer is right there, 3.688. You can truncate. And it's done. Some calculator work. All right, put away the calculator. Done. No more calculator. I don't want it anyways. All right, can we integrate this without a calculator? So this has a hook. What's the derivative of 3t minus 1? It's 3. What was it before? What did it become? What adjustment do I need to make? Then the hook is released. And then I add 1 to the exponent and divide. And we're going from 0 to 1. So we're not done yet. So this is 1 over 15. I'm going to plug 1 in. So 3 times 1, take away 1, that's 2 to the 5, minus. Again, it's 1 over 15. I'm going to plug in 0 now. That's negative 1 to the 5. And if I put this together, it's fine. 2 to the 5 is 32 over 15 minus, now 2 negatives will make that plus 1 over 15. So altogether that answer is 33 over 15. You can actually leave the answer like this for full credit if it's not multiple choice. Number 10, I want to do a definite integral with absolute value. This is a graphing question. So take what's inside the bars equal to 0. That gives you the vertex. So the vertex is at positive 1. Then I take the bound. So at negative 2, I plug in and get the answer 3. At positive 2, I plug in and get the answer 1. And then I draw like a check mark. And then we have 2 triangles here. The one on the left and the one on the right. So the one on the left, the base of it is 3, and the height of it is 3. And then we add the second triangle, 1/2, the base is 1, and the height is 1. So if I put it together, it's 9 over 2 plus 1 over 2. So if this was multiple choice, do you have the ability to go 9 plus 1 is 10 and then divide by 5? If it was not multiple choice, that's the answer. If it is multiple choice, you need to know how to calculate it. All right, next page, number 11. Which of the following is a right-hand Riemann sum of this, right, using 3 rectangles of equal width? So the width is going to be 4 take away 1 divided by 3. So that's from the bounds and how many rectangles you have. So the width is 1. And then we're doing a right hand. So the first rectangle goes 1 to 2. In the right, I'm going to use 2. So if I plug 2 in, I don't need to simplify it. But if I had to, I could. Plus, the next one goes 2 to 3. So I'm going to plug 3 in for a right-hand Riemann sum. And then the last one goes 3 to 4. And for a right Riemann sum, I'm going to plug in 4. And that's it. So if I calculate it, it'd be different. Just for fun, maybe I'll do it. 4 plus 5, that's 9, take away 8. This one is 9 plus 5, 14, take away 12. This one is 16, 21, take away 16. All right, so that answers 8. All right, which of the following is the trapezoidal rule for the same one? All right, I'm not going to redo everything, but trapezoidal rule starts with 1/2 times 1. Well, it's 3 subdivisions. Oh, they both have 3. So the width is 1. So how does it go? So it's 1/2 times the width, which is 1. And then I take the first height. So if I plugged in 1, I said the answer was, did I plug in 1? I didn't plug in 1 for it. So if I plug in 1, 6 take away 4, that's 2. Then I double the next height. So when I plug in 2, the answer is 1. Then I double the next one. When I plug in 3, I said the answer was 2. And then when I plug in 4, the answer is 5, and that's not doubled. And there's your answer. And then if you had to simplify it, you could. All right, next one. Can you integrate this? This is just indefinite integral. So I'm going to set this up a little different so you can see it. So it's cosine x to the power of 3 sine x. So the hook comes from here. So the derivative of cosine is sine. So that's perfect. And then I add 1 to the exponent and divide, and don't forget the constant. All right. How about this one can you evaluate? So if I look, what's the hook is 3x squared from the derivative of inside the parentheses. All right, now we have to make an adjustment. So what was it before? And what did it become? So it's 4 over 3. Now we're going to circle the hook and release it. Our answer starts with 4 over 3. And then what's the derivative rule for cosine? It's sine. And that's done. Plus c. Number 15. All right, I think this helps with the number line. So from 1 to 3, the answer is 6. From 2 to 3, the answer is negative 3. So then what's the answer from 1 to 2? So what number, when I add it together, gives me 6? So this must be 9, because 9 take away 3 gives me 6. So I think with the number line, it's easier to see. Number 16. We have a piecewise of a semicircle and a line, and it says integrate from negative 3 to 5. So this, from negative 3 to 3, is part of it. That's a semicircle. That's 1/2 pi r squared, and the radius is 3. Now it's positive because it's above. And then we're going to subtract this part. So this is a triangle. So it's half the base. So the base is 2, and the height is 4. And you could actually go plus and use negative 4 for the height and do it. But there's your answer. If you want to, it's 9 over 2 pi. What is that? Minus 4. But this is perfect up there. All right, number 17. Let's write this calculus friendly. So it's 5 minus 2x to the 3, negative 3 dx. And then the hook. So the derivative of what's inside the parentheses is negative 2. We haven't integrated yet. What it was in front was a 1, and it became negative 2. So that's the adjustment. Then we circle the hook and unhook it. And our answer starts with negative 1/2. And then you add 1 to the exponent. That's negative 2, and divide by that exponent, plus c. And you can leave the answer just like that. All right, evaluate this. I'm going to write it friendly. So that's to the 1/2. But the derivative of what's inside the parentheses is unlike terms to what's in front. So that's an indicator. This is u substitution. So I'm going to let u equal x minus 1. And then x equals add 1, and then take the derivative to both sides. And this is what I'm going to use over here. I'm also going to change the bounds. So I'm going to plug 2 into here, and 2 take away 1 means it's now 1, and then 1 take away 1 is now 0. And then plug in. So x is u plus 1. And then x minus 1 is u to the 1/2. Oops, and dx is du. All right, now we're going. Now I need to do some algebra. So if you want, that 4 could actually be in front of the integration. And then you can just focus on u to the 1/2 times u. Add the exponents, it's u to the 3 over 2. U to the 1/2 times 1. And now integrate. So we're going to add 1 to the exponent. That's 5 over 2, and then the reciprocal. We're going to add 1 to the exponent, and then the reciprocal. And then I'm integrating from 0 to 1. When I plug in 1, 1 to any exponent is 1. So you end up with 4, 2 to the 5th, plus 2/3. You don't have to simplify it. When I plug in 0, the answer is 0. So there's my answer. Done. Number 19. All right, a region is bounded by y equals 3. That's a horizontal line. And that parabola. Now, this is in HK form. where h is positive 1 and k is 0. If I plugged in 0, negative 1 squared times 3, it's right here. And I'm going to match it on the other side, right there. It's a skinny parabola just looking like that. And then this shaded part right here. So sketch and shade it. Show an integral set up for the area of what you just did. So it goes from 0 to 2. In its top, which is 3, subtract bottom, which is 3x minus 1 squared dx. And that's it. So from 0 to 3, top subtract bottom, dx. Done. 20. Find the average value of this from 0 to 3. So I'm going to integrate from 0 to 3. And then divide by the difference of the bounds. So show integral setups and integration steps. So I actually have to do the work. So this is really 1 over 3. I'm just going to write that in front. And then I'm going to integrate. So add 1 to the exponent and divide. Add 1 to the exponent and divide. And then minus x. And that goes from 0 to 3. So we have 1/3 in front. I'm going to plug 3 in. When I plug in 0, it's all 0. So I don't need to plug 0 in. And then I don't need to simplify it. And that's my answer. And B, find the values of x where the function takes on its average value. So now I actually do have to simplify it. So 27 divided by 3. That's 9. 9 over 2 minus 3. Let's see if we can do this. So 9 take away 3 is 6. 6 is 12 over 2. That's what, 21? And then, once you have that, you'd make it equal to this and solve it. Now, this is definitely one where you would use a calculator, even though it doesn't say it. So on the test, likely this answer is simple, and you would actually make it equal to 0, and then factor it and solve it for the answer between 0 and 3. So if I had my calculator, I would then solve it. Where'd it go? So again, if you have a question like without your calculator, it would be an answer where you could make it equal to 0 and factor it. But this one, I did not set up one factorable. So, menu algebra solve, and then we're going to type in x squared plus x subtract 1 equals 21 over 6 comma x. And we get negative and positive. So we want the one in the interval, which is 1.679. But you understand the setup, that once you do the average value, make it equal to the function, and then solve it. And if it was a nice answer to solve, you'd make it equal to 0, factor it, and you get your answer. All right, last page. Number 21. At every point, the slope of this curve is given by this equation. Find an equation that flashes through. So, x, we first need to find f at x by doing the integration of this. So we're going to make it friendly. Then, this is to the 1/2. Then the derivative of this is 2x. And what it was over what it becomes is 1/2. Then you can circle the 2x and unlock it, let it go. The answer starts with 1/2. We're going to add 1 to the exponent and then do the reciprocal, plus c. Now the 2's do cross out. I have more work to do, so I want to simplify it a bit. Then it says to plug in 0 and 1. So if I plug in 0 here, so I'm going to make it equal to 1. I have 1/3. 0 makes this still an ugly answer. So honestly, it would be nice if you could square root this. So if this was x squared plus 4, then you could actually simplify it. This one, there is not. This is irrational. I mean, we can subtract it to the other side. That's what c equals. And then you would write the equation of that would be 1/3 x squared plus 2 to the 3/2, and then it's 1 minus all of that. Done. All right, number 22. Here we have an equation, this curve, and it says find the area of this. So it's an integration question. So we're going to integrate from negative 0.5 to 1. And it's just top subtract bottom. So that's x squared plus 1 to the 3rd minus 0, or just that, dx. Then it says find the volume with y equals 8. So here's y equals 8. So if I'm revolving, that's now pi r squared. Same bounds. And the question is, when I revolve, is there a space here? And there is. So there's actually a big radius and a small radius. So let's get that in there. So the big radius from 8 to the bottom, from here all the way to the bottom, would just be 8 subtract 0, which is 8. And then you subtract the small radius, which is from where you're rolling down to the top of the area, which is the curve. So it's 8 subtract x squared plus 1 cubed. So you have the big radius subtract the small radius, and you have the setup of it. All right, I made a mess of that one. Part C. Find the volume using cross sections that are semicircles. So that means each cross section here are semicircles. So what I'm looking for, the setup, again, is negative 0.5 to 1. It's pi r squared divided by 2. That's the formula for area of a semicircle. And then I need to recognize that that's really the diameter going across. So when I go top subtract bottom, that's the diameter. When I divide by 2, now it's the radius. So I'm going to take x squared plus 1 cubed and divide it by 2. And now we have the setup to find the volume using semicircles. All right, last one, number 24. Tortoise. I bet you don't know. I have a tortoise at home. True. His name is Flash. All right. The graph at the right, it's a true story, of the velocity of tortoise here. Now I'm thinking of my tortoise. Famous rate. So we're given the rate of its going. So right here, here's the velocity of that tortoise given it. It says, what's the average velocity? So that's an integration question where we integrate from 2 to 7. So we're going to integrate the velocity and divide by the difference of the bounds. So I'm going to integrate from 2 to 7 and divide by the difference of the bounds. Well, the numerator, we're told the answer is 17. So it's just 17 divided by 5. And what are the units? Well, the average velocity would be velocity. So it's in meters per hour. All right, part C, part B. All right, can you integrate from 1 to 7? So from 1 to 7 is this part. Now, we're already told 2 to 7. 2 to 7 is 17. I got that already. Plus, what's missing is just 1 to 2. Just this part. So that's a rectangle. That's 1 times 3. Well, that's 3. So if I put that all together, that answer is 20. And this is write an exact sentence telling you what that number means. So let's go from 1 to 7. So that is from 1 p.m. to 7 p.m. What happened? The tortoise traveled a total of how many miles? Or is it miles? Meters. How many meters? 20 meters. Done. All right, Mr. G Math over and out. Good luck on that test. I know you can do well. I believe in you. You're going to do great. Till next time.